Welcome everybody on today's webinar, which will be about ConSteel's programming interface, and it will focus on the Excel commands of ConSteel programming interface. My name is Roland Doka. I will be the presenter today, and I work as a support engineer here at ConSteel Solutions. Some practical information about the use of GoToWebinar. There's a red arrow on the control panel with which you can hide and open the panel, and you can ask questions at the questions tab, and I will try to answer them at the end of the webinar. The content of today's webinar, as I said, it will focus on the Excel commands of ConSteel programming interface. First, I will give you a short introduction about the commands related to Excel, and then I will show you a live demo of these commands and how to use them on a short example. I will show you a user project, which is a very nice 3D parametric whole, and all of the parameters are based on Excel import. And at the end of the webinar, I will show you how to create a general script to import data stored in Excel. So on our YouTube channel, there is an introductory webinar about ConSteel programming interface, which will show you how to create variables, how to use the functions of the programming interface, and what are the possibilities in ConSteel programming interface. So it is uploaded already on our YouTube channel. You can watch it there, and we have a wiki page for this programming interface, where you can find all of the command descriptions, all of the syntax rules, and also there are downloadable model scripts. And also we have, of course, our YouTube channel, where we upload tutorial videos and webinars like this will be uploaded too. So there is plenty of materials if you want to use this function of ConSteel. Okay, let's move on to the Excel commands itself. In ConSteel 11 we have 4 Excel commands so far. The first one is the Excel open command. This is basically a prerequisite command for all other Excel commands, because you have to open an Excel file which will be used for the data transfer between Excel and ConSteel. Here you can see the syntax rule. We will check it on a live demo. And also we have the Excel read cell command, which will read value from a specified cell of the opened Excel worksheet, and it will create a variable in ConSteel programming interface, and then it will store the value of the specified cell of the Excel file in that variable, and it can be used later on in the script. The next one is the count field rows command. This is very useful. This is a very useful command if you are dealing with cycles and repetitive commands. So we will check this too in our example, in our live example. But basically, it will count the field rows in an Excel file, and it will store that value, that number, in a variable. And then we have an Excel close command, which will close the opened Excel file, and that's all what it does. Okay, so these are the commands available yet in ConSteel 11. These Excel command package will be expanded in the future, of course. Okay, let's move on to the live demonstration, for which I have brought you a simple Excel file which stores some data. Just a very simple example. We have some data data for cross sections, and this is a frame example. So we have two cross sections, one for the column and one for the beam, and we have some dimensions: the height of the column, the height of the top point of the frame. We have a span, and we have some supports data. So I will open a new ConSteel model, and when you open a new ConSteel model, you see that this is the control panel of ConSteel programming interface. Down here it has 3 buttons. By default, the first one is the open button. If I click it, the panel will be opened, and it will be expanded. The second one is an open button. So if I click it, I can load previously created scripts to this panel. And the last button is the run button, with which you can run the script you have loaded or written. Okay, so I will delete this previously created script, and I will open the panel. And how you write your commands and what commands do you need to write in this panel for this Excel import. First one, as I mentioned before, we have to use the Excel open command, and then now we have to give the path of the Excel file where you store your Excel file on your computer. So I will define it. This has to be defined between apostrophes. So I will write the path of it. Okay, and if you don't know what are the syntax rules for each command, you can go up to our wiki page on wiki.consteelsoftware.com address, where you will find this link. If you click it, you will direct it to the wiki page of ConSteel programming interface. Here you can find all the necessary information for each command. So first it starts with the basics. So how you can define variables, what are the mathematical operators you can use in your scripts, how to define cycles or if-else statements, and then we have our command descriptions. Basically, we can create all kind of objects what you can use in ConSteel, and we can create loadings, load cases as well. So, and at the end of it we have downloadable model codes. So let's check out the Excel command package, and here you can find all the Excel related commands. First we need the Excel open, and here you see that the syntax rule of the command is this one. So you have to write the command, and currently this is the only command attribute, the path of the Excel file, and it has to be defined between apostrophes. For every command you will find a command parameter table where all of the command parameters will be listed. So right now the path of the Excel file is listed here. You can see that it is a required attribute, so you always have to give this. And you will see a short description about how to define this attribute. Okay, so next thing is to load the data from the Excel file. So I will again go to the wiki page, go to the Excel read cell command to check how we can do this. Here you can see that Excel read cell is the command. We have to define the name of the worksheet in which we are working. We have to specify the name of the column where the program can find the value, and also the number of the row. And then at the end of it we have to define the name of the variable which will be created to store the value. And as you can see, all of the parameters are of course required. So let's go back to ConSteel. Of course, and here you can find a copy-paste sample for this command. So I will use this one and copy-paste it. So okay, first is to define the name of the worksheet. The name of our worksheet is data, as you can see here. So I will write data here. And then we have to give the name of the column, which is column B, and the row will be number 2 for the column section. Column B, row 2, and the variable which will be created to store this data will be called column. Okay, and this we will repeat this process until we have data to read from Excel. So next up is the beam cross-section, which is stored in this third row. And I will name this variable to beam. Next we have a column height, a top height, and a span variable. So we will create a column height which is stored in the 6th row. We will quickly create a top height which is stored in the 7th row, and we will create a span which is in the 8th row. And we have one more variable, which is the support condition on the column basis, which is fixed, and it is stored in the 11th row. And I will call it column base. Okay, so now we have all the data from the Excel file. We can move on to load the cross-sections and build up this parametric frame. So first I will load the cross-sections. For that I will use the load section command. Of course we can check this command on our wiki to check how you have to define it. And what section do I want to load is the column section, which section is stored in this column variable. So I will give column here, and it will load that section. Next step is the beam cross-section loading with the variable. Okay, and then we can move on to create the structural members of this frame, for which I will use the create command. So I will type create. I have to give an ID for this structural member, which is an optional parameter. If you would check on the wiki, you would see that it is optional. It is optional because if you want to place any, for example, a point load later on your script to a specified structural member, you have to know that what is the member on which you want to place the load. So this is and how you define it of course with an ID. So if you want to use later a beam for this kind of purposes and place other objects on this beam, you have to define an ID manually, but if you don't need it, you don't have to type in. So let's call this C1 column 1. I will create a structural member with a section of column. Okay, and now we can move on to the coordinates. The start coordinates are 0 by x, 0 by y, and 0 by z. The endpoint coordinates of the structural member will be 0 by x, global x-axis, 0 by the y-axis, and the height will be the last one, the z coordinate, and it is stored in the column height variable. Okay, we can move on to the next structural member, which is the first beam. So the ID will be B1. It will be a structural member, but not with a column cross-section, rather than a beam section. The start coordinates will be the end coordinates of the beam, I mean the column, and the end coordinates will be in x direction. It will be the half of the span, so span divided by 2. The y coordinate will be 0, and the z coordinate will be the top height. Okay, we can move on to the second beam, where the start coordinates are the end coordinates of the previous beam, and the end coordinates are the span of the building by x coordinate. In y direction it is 0, and in z it is the column height. And we have one last structural member to create, which is the last column. The start coordinates, and then we define the end coordinates, which is this. Okay. Last step is to create the point supports for this frame. So we will create an object again. So I call the create command. We have to define an ID. Let's say it will be the S1 support 1. The object will be the support point. And now we have to give that on which structural member do we want to place our point support. We want to place it on the first column, so the C1 ID will define that column. And we have to give now the type of the support, which data is stored in the column base variable. So I will use that variable, column base. Okay, and we have to define the coordinates of this support, which is right now at the origo. Okay, the next point support will be the support 2, and it will be placed on the second column, but the coordinates of it by x coordinate it will be the span. Okay, and that's all. Last step is to close the Excel file. Okay, and if we will click on the Run button, ConSteel will open the Excel file and then store the data what it finds on the specified column and row, and store it in a variable, and then you can use those variables in commands. And as you can see, this frame is built up from those parameters, and if I would change these parameters in the Excel file and click on the Run button again, another type of frame would be created. Okay, so this was the first short demo of how you can use these commands. And I would like to highlight that if you don't know something, that how you have to write a command, or what is the syntax rule for a command, you can always go to the wiki page, and you will find all the necessary information for each command. Okay, so now we can move on to our next example, which is a customer project, a parametric 3D hall, and not one but three 3D halls. In this customer project, the customer used the same tools as I showed you before. So for example, let's say this is the first one, the first of the customer project. It is an Excel file, and it stores all the necessary geometric parameters for a tapered hole. And those cells which are highlighted with this blue color can be modified, and those parameters are stored in the ConSteel programming in ConSteel with the ConSteel programming interface, and these parameters will be used to build up this type of hole. You can change a really lot of parameters. You can change the span, the length of the building, basic parameters like column height, top height, but you can also choose that what kind of purlins do you want to use, what should be the material of the purlins with this drop-down menu. You can choose different kind of cross-sections for purlins and stuff like that. So basically every parameter can be controlled from this Excel file, and of course there is a corresponding ConSteel programming interface script file for this Excel file, and I will show that in a minute. So let's load it. So again, it starts with the Excel open commands and continues with the create commands and cycles and the comments. And let's press the run button. It will again open up the Excel file, and it will work for a while, not too long, but it needs some time until it builds this building. And as you can see, this was the model and the data which is stored in the Excel file. It is a tapered hole with gable frames and main frames with purlins moved to the top flanges of the beams, connected with link elements. It has a bracing system too. It was built up with one click. So if you would need another kind of parameters, you would just change some things, change those parameters in the Excel file, and run the script again, basically. So this is the first model for this 3D hole, but the user created two more solutions for this hole. He created a tapered truss solution. So again, you have your Excel file, and you have your parameters what you can modify. And currently the main frames are not tapered. The main girders are not tapered, but it's a truss. And again, if we would run this script, first I will load the script to the panel. And run it. It will create another type of building in about 10 seconds or so. Okay, and this building, as you can see, is now a truss 3D hole. And there is one more solution, which is a truss solution, a completely truss solution. And here you can specify that what kind of girder type do you want to use. So these are your options, but if you want, you can change it to the K type, which is this one. You can use the K plus T type, or you can use the N type, and also you can change the materials, the cross sections, and every parameters for this hole. and let's quickly just to show you to import it to ConSteel. I will open the script file, and then I will move the whole model a little bit left and press the run button. And the model will be created here. So as you can see now, here is our whole with the parameters of that Excel file. So this is the first approach of using these Excel commands, and now I would like to show you the other approach, which uses cycles, and with that solution you can import a whole model again to ConSteel. And for this I have brought you another Excel file which now stores, which has two worksheets. First is the node coordinates and the other one is the member data worksheet. In the member data worksheet we have three columns. The first columns is represents one member. So for example, the first member has a start point and an end point. The start point has a node ID of 1, and the end point of the member has a node ID of 2. On the other worksheet, the node coordinates worksheet, you see that each of these node coordinates, the first column are the node IDs, has their X, Y, and Z coordinates. So for example, if we choose the 16th node, I mean the 16th member, sorry, the start point has a node ID of 28, and this node has a coordinates like this. So for example, this is X, Y, and Z coordinates, and there are lot of members. So currently more than 1,000 members stored in this Excel file, and we can create a general script for this to import it to ConSteel. And I would like to show that how you can do this. So first I will open up a new ConSteel and open the csPI panel, and the first thing of course is the Excel open command again. Right now my file is located on my C drive, okay. This will open the Excel file, and the other thing that currently we only have coordinate data in this Excel file, so we don't have sections in this file, so we have to load a section manually. For this we will use a macro section, and I will show you on the wiki that how you can find the macro sections. So let's go back to the commands on the wiki page, and we have a command description for macro section. Here all of the macro sections are listed, and right now we will need a cold formed circular hollow cross section, so this one. And as you can see, this is that section, and here is the sample code what you can use in your script. And as you can see, the two required parameters for this cross section is the outer diameter and the plate thickness. The outer diameter is located here, so currently it is 300 millimeters, and the plate thickness is this one, the 18th millimeters. Okay, so let's Control C. Let's copy this and paste it to our panel. Right now we use 100 millimeter outer diameter and a 10 millimeter inner, wall thickness. And the name of it, let's say it will be CHS 110. Okay, so now we have our macro section loaded into the model. Next step is first to only import one member of that Excel file, and then we will do a cycle to run through all of the members. So I will use the Excel read cell command, and first we are going to work. Sorry, I will quickly close these. Okay, so we are working from the node coordinates, the member data worksheet first, and we will type that, member data, and we will work from the B column. We will store the IDs of each node. So we will need the B column and the first row of that column, and we will store this value in a node ID start variable. We will do this for the endpoints also. So Excel read cell command member data worksheet, but now not the B column will be used, but the C, and of course only the first one will be stored now, the first row, and this will called the node ID end. Okay, the other thing that we can use comments. So if you have a longer script, it is visible if you use comments for explanations of your code. So this is the import node IDs. This part is the section loadings. Okay, the next step is to import the coordinates of the nodes which has the ID of the node ID start and the node ID end. So I will comment this import coordinates with the Excel read cell command, but right now not the member data worksheet will be used. We need the node coordinates worksheet. Node coordinates, and we will use, first we will search for the X coordinates which are stored in the B column. These are the X coordinates. The column is B, and the ID of the node is the node ID start, is stored in this variable. Okay, and we will create a new variable to store the X coordinate, and I will call it start X. Okay, and we will repeat this for the Y and the Z coordinates too. So the Y coordinates are stored in the C column, and the variable to store it will be called start Y. We have one more coordinate, which is the Z coordinate, which is located in the D column. Okay, so these were the start point coordinates. We have to import the endpoint coordinates too. We will again use the node coordinates worksheet, and again we will, for the x coordinates we will use the B column, but right now not the start ID is needed, but the end IDs. And the variable will be called end x. Next one is the end coordinates for the y direction. The column is C, and we have the z direction where the column is D. Yes. And I will call it end z. Okay, so we have imported the coordinates for one member, the first member, start and end point coordinates. We can now create our member, for which I will use the create command. I will right now give an ID, anything, and then we will need a structural member. The section of it will be the macro section which we created in this row, and the name of it is this. Okay, and now we can define the coordinates. First we will need the start x coordinate, but because in the Excel file these coordinates are in meter dimension, we have to multiply it with 1000 to get millimeters. So I will multiply it with 1000. Okay, the next one is the start y direction. Also multiply it with 1000 to get millimeters, and we have z coordinate for start point, and again it is multiplied. Okay, next one is the end point coordinates, and x and y. And then the end z coordinates, and it is also multiplied with 1000. And then at the end of it we can close our Excel file. And if I run this script and I made no mistakes, one member will be imported to ConSteel. Let's check it out if it works or not. Let's click on the run button. Program said the operation has succeeded, and we have our member here. So it seems that so far we are good, and we can continue to define a cycle, and that is what I'm going to do. For this I will use the other Excel command, the Excel count field rows, which is I will quickly check it on the wiki. Here we have the Excel count field rows, and as you can see it has 3 command attributes: the name of the worksheet, the name of the column, and the name of the variable in csPI. So first I will have to again define the name of the worksheet. I will type my command here. Name of the worksheet is will be member data, because in this column, in the A column, each member has its own unique ID. So these are the IDs of the members, and this is what I need, the number of these members. So I will count these rows. Member data. The column will be A, and the variable which I will use to store the number of the members will be member, let's call it member ID now, or member numbers. Okay. Okay, the next step is to define our cycle. Each cycle starts with a for definition and ends with an end definition, and the program will automatically highlight the cycle with this green background color. So this will be repeated a number of times, and how we define this number of times, we need a running parameter. So first I will define a variable which will be our running parameter. The start value of this parameter will be 1, and it will automatically increase by 1 until it reaches a certain value, which value now will be the number of the members which I have here stored from the Excel file. So member numbers, okay. And if I want, I can use this $n variable as an ID for each of the members. So here with this I can define a unique ID for each of the members. Okay, and one more thing that I have to do is to modify the node IDs of the members. So I will rewrite this number 1 because previously we only imported one member, but now we need all of the members. So we will run through all of the members, not just the first one. Okay, and this is what modifications were necessary, and we can click on the Run button. And now all of the members should be imported to ConSteel, which will take some time, not too much, but eventually we will have our model. I would like to highlight that right now only coordinates are imported to ConSteel, but if you would have your member release conditions, supports, loadings, load cases, or any kind of data stored in your Excel file, that could be imported with this methodology easily, and you can create your own general import script for this kind of Excel worksheets. Okay, so as we can see, we have our operation succeeded, and this was the model in the Excel file. Okay, this is what I wanted to show you. And one more thing, that on our wiki page we have the customer project which I have showed you before uploaded to the downloadable model code section. So you can download the Excel file and the, sorry, this is it. So you can download the Excel file and the script file too, and test it for yourself if you want to. Okay, so that is nearly the end of our presentation. We have a website where you can, if you want to test ConSteel or test csPI itself, you can download our software from this page. We have a Facebook channel, YouTube channel, we have a blog and a LinkedIn account where you can get our latest news, events, you can check out our webinars and other kind of videos. Also we have an email for any kind of price quotations or questions about the software, and if you have technical or engineering questions, you can use the support@consteel.atlassian.net email address, and we will answer your questions. Okay. This webinar was the last series of our autumn webinar series, and we had two more webinars in this autumn webinar series. The first was a BIM focused webinar with Idea Statica Connection, and it is already uploaded on our YouTube channel. You can check it out in case you have missed it. We had a comparison of different stability design in Eurocode 3 webinar. This is also available on our YouTube channel. And this webinar about the csPI will be uploaded in a few days also to our YouTube channel. Okay, and thank you for your attention, and see you next time.